Thank you, Simon. And of course, we all will have time to answer some questions. In fact, we'll have a little opportunity at the end to take your questions. So please take copious notes, and we look forward to taking those questions at the end of our four speakers. Next up, Christian Morgan comes to us as the Vice President and in charge of marketing for Inbicon. I've already heard a presentation one of his colleagues has done from Inbicon. Throughout his career, Christian has been working with energy technologies, first by building a waste-to-energy facilities, plural, and since 2001 with the development of a new technology for the production of cellulosic ethanol. From 2001 to 2006, he was the project manager for a large European R&D project that was actually partially funded by the EU. The developments of the project led to the formation itself of Inbicon, where this technology is now still being matured and brought to commercialization. Since the completion of the project, Christian Morgan has been responsible for business development and marketing at Inbicon. He holds a master's degree in engineering from Technical University of Denmark. So please join me in welcoming Christian. Thank you.
Thank you, Thomas. Good morning, everyone. I'd like to take us back a little further than where Simon started, because Simon mentioned that his company sort of started on great statements, and I would like to take us back to the 90s, where the Minister of the Environment and Energy and Environment in Denmark said that he would no longer allow burning of biomass in our wheat fields. So he asked the energy companies in Denmark to start using wheat straw as an energy source, and the energy companies said, thanks but no thanks, because that will ruin all our boilers and we don't want that. And then the minister said, I will ask you nicely again, and we said, okay, but you have to pay us for it. And we figured out a way, and we started working with wheat straw as an energy source. Now, we tried three things. One of them was co-firing with coal, and we managed to do that successfully, and we have developed that technology, so we're now co-firing wheat straw in Denmark with coal. It has its limitations because you can only add around 15% wheat straw to the coal. The other thing we did was to pay boiler manufacturers in Denmark to develop straw-fired boilers. And they did that, and they were quite successful, and we built a number of plants in Denmark that fire wheat straw exclusively and produce energy. The third thing we tried was to wash the straw and remove the salts that cause corrosion and fouling in our boilers. Now, it worked pretty well. The washing removed all the stuff, but now you suddenly had a wet biomass, and talk about moisture content in the biomass, so the management of the energy companies thought that was not such a great idea. Well, history went on, and we built out the straw-fired boilers in Denmark, and the technology was sort of halfway shut down because we had now completed our own goals in Denmark, and that's where Cleantech came in and took over, and they have now successfully globalized this technology. A couple of people sort of looked into the washing technology and saw that, well, maybe there were other things we could do. So we sort of took that technology and looked into other options for further developing that. And the results of that is, let's see if I can make this work, is where we are today with our technology. We are now producing cellulosic ethanol in Denmark, and it's available nationwide. Statoil, the Norwegian oil company, is selling cellulosic ethanol blended in as a 5% blend in one of their products at 98 gas stations in Denmark. So we've managed, as an offspring of a political decision made in the 90s to use biomass as a source of energy, to develop actually several technologies that are now being deployed. And of course, we're way behind Cleantech, but we also hope to do what they have done. We have taken a different approach this time because we wanted to keep some of the technology with ourselves and to profit on that ourselves, and not just as a plant owner, just pay for the development of the technology. So what I will be talking to you about today is a little bit about the plant that we have in Kalundborg. And since the theme is the international developments, I will go through the plant and I will acknowledge some of the differences that we see when we go out internationally and try to develop projects, because in each and every part of this technology you will see, or we see, challenges when we go outside our own backyard. So this is a picture of the plant in Denmark. And it's a 1.5 million gallons per year facility, and it uses 30,000 tons of wheat straw once we reach the nameplate capacity. It's the largest of its kind in the world, and I can definitely tell you that it's the most expensive one. You can see that we put a little effort in the architecture, and that is maybe one of the first challenges, that when we build plants in Denmark, we do tend to spend money on looks and architecture. And although I haven't seen any of the Cleantech's plants in China, I guess that the architecture is at least different. So the front end of the plant is our biomass handling. And for us working in Inbicon, we never spend, or at least in the development of the technology, we never did spend much consideration on the biomass handling, because we already had that at our power plants. We actually downscaled our biomass handling facility to suit the size in the demo plant. But when you go abroad, when you go to the US, and you've all heard this probably yesterday, there's a huge, at least mental barrier about collecting biomass. Now, we've heard that it can be done in China with political will. And I fully agree with Simon that we have done it in Denmark, it's been done in China, of course it can be done in the US. We're absolutely confident with that, and you guys are sitting on a pot of gold. The amount of biomass out there that can be taken in and turned into valuable products is just extreme. When you go to other countries, we also have activities in Asia. It's a different biomass altogether. If you move into Brazil, they have the bagasse lying in big piles, so you need to develop new handling systems. Also, moisture content and so on changes. So that is one of our challenges on moving outside our own system with the very well-developed biomass logistic systems that we have in Denmark, that we're facing a challenge that goes outside the core of our technology, and we need to deal with all our clients asking us, well, where do we get the biomass from? And we also heard this morning that when you address a bank, one of the things they will ask you is, well, what kind of biomass do you have access to? And for us, as the engineers working to develop this technology, it is something that we have to take into account. Next part is the pretreatment process, and I call this the don't try this at home slide, and we have it in our presentation as a standard to scare off any potential competition. But my point here is that we're dealing with high pressure technology that is, I won't call it very complicated, but you still have standards that you have to adhere to. When you move into different engineering standard regions, there are other standards for pressure vessels and a lot of technical details that provide a challenge. So for us as Danish engineers, we couldn't just fly a bunch of engineers over here to the US and start building a plant. So we have to work with local engineering capabilities to make sure that we adhere to local standards. And of course, that's the same if you go to Malaysia, China, Brazil. They all have different standards. So that's a challenge too. Enzymatic processing, I'm not going to say much about this because this is a quite simple process. This is where we add the enzymes. And of course, we are fortunate enough to be a Danish company, and two of the largest enzyme developers, Gentherm and Novozymes, of course, are also Danish companies. So in that respect, it helps us to be a Danish company because we have a good dialogue with these companies. We work with both of them, and they both supply enzymes to our plant. And of course, they have big activities in China and especially here in the U.S., of course. So that helps us a lot. Partnering is necessary when you're in this game. Here are some pictures from the operators' room. And in Denmark, we design everything with a very high level of automation because of the salaries in Denmark are very high. So the less people you employ, the better. And optimization and automation always helps to improve the OPEX of the plant. And of course, when you go different places, again, you might not want the same level of automation, so you might want a simpler plant, more manually controlled plant, and that's a challenge. The back end of our technology is actually an example of where we've gone the other way, because those are simple, very simple standard fermenters and distillation towers and dehydration units, and all of that is basically this technology is supplied from an Austrian company, but the whole technology is developed here in the U.S. through the growth of the starch-based ethanol industry. So we have sort of piggybacked on that. You know, there's no reason to invent the wheel once again. So here's just an overview of our plant with the biomass inlet and the processing facilities and the fermentation and distillation towers and everything, and a few figures around the plant. So these are for your reference. I will just tell you, just go briefly through where we are with our operation, just to give you a background on the challenges that we're facing in developing projects, because we're somewhere along the probably around slide 4 or 5, as I remember, of Hanneline's presentation. So we're in between proven technologies and still doing that. Last year we had the commissioning and trial run of the plant, and in the second half of the year we've sort of run the plant in a two-stage mode. So for 2 weeks we would run the upstream part, the processing of biomass and the pretreatment and the enzymatic hydrolysis, filling up the fermenters, and in the following 2 weeks we would empty out the fermenters and produce the ethanol. We still had a lot of things to do and work on before the plant sort of started, you know, progressing towards the capacity and the uptimes that we wanted. We had a lot of issues with our DCS system. It was programmed from scratch. That's never been done before. So alarms were just piling up on the screens. So we did a lot of work on that, and that's where we are right now. So in 2010, we managed to prove the concept and prove that we can produce all these products. We're selling our products on a commercial basis. We're selling the cellulosic ethanol. We have Statoil as our main off-taker, but we're also selling to other blenders in Europe. We are providing our lignin pellets. The original reason that we started in this business to provide the clean fuel for the power plants, we're providing those to the largest energy company in Denmark, Dong Energy. They also happen to own Inbicon, so that's a good match. And the C5 molasses is now currently being sold to anaerobic digesters in the local area. In Denmark, we can get a higher price for our molasses if we use it as a cattle feed, and that's one of the objectives that we will be dealing with this year, trying to prove the feed value of the molasses. Again, moving into different marketplaces, there is a challenge with your products because it's not everywhere in the world that they have a huge need for cattle feed. So again, you have to adapt to local conditions. This is the sales slide, of course, but these are some figures that I always get asked, so I might as well put them in the process. We produce around 40-some gallons of ethanol per ton of biomass that we put into the plant. We have high solid contents throughout the process, and that gives us a good OPEX and yields. So where are we at now? At the first quarter of this year, we continued our campaign, our